Hello everyone, November the 18th. Alright, we have a tough one today, and we haven't solved this one yet. Oof. Tough luck. Oh, erect the fence. I remember this problem. I mean, I've done it before and I remember it, but I don't remember the solution. You're given an array of trees. Represents the location of the tree in a garden. You're asked to fence the entire garden using the minimum length of rope, as it is expensive. The garden is well fenced only if all the trees are enclosed. Return the coordinates of trees that are exactly located on the fence of the perimeter. So in this one is going to be this 2 0 3 3 2 4 and 4 2. Yeah, like that. I don't remember. Let me think. Well, okay, find the leftmost. This definitely will be on. And then topmost, bottommost. And not necessarily. Not necessarily. I think is for each column. I need to find the topmost. I think that was my solution back then. For each column, from left to right, for each column, I find the topmost and I find the bottommost, right? And I find the topmost, so we have a topmost along the way. And then I'm gonna try to make connections. So I'll connect the two, okay? And then I try to connect the next one. So if because we have to connect the top ones. So what we want to see is if any of the angles is wrong, then that one can be eliminated. Any of the angle. What do you mean? Not the angle, the slope. Okay, so we sorted based on x coordinate and then sorted and then on this, so we just go this. Any two, okay? And then find this on the next one. If the slope is larger than the previous slope, then I can eliminate and then we can do this, because that would definitely include this one, right? Then we look for the next one. Hold on. So choose this too. Yeah, we have to sort based on x-axis. So we're gonna go from left to right, okay? And then from the left, we're gonna go the top left. Okay, top left. Then we go on the top. Alright? And then we go on the top. If it's a convex, then we eliminate the previous one. And we reconnect this. And then we keep moving to the next one. So the slope has to be smaller, right? And smaller. If any one is bigger, so that's the top half. Now we're gonna handle the bottom half. Okay. Bottom half, it has to get bigger. Okay. I feel like this is how I was doing it last time, but oh. Alright, let's just do this. That was yesterday. So when the trees are sort, okay, key equals lambda tuple I want from small to large. Oh, that's okay. Then we just sort them. Okay, that's okay. Okay, I sort. All right. And then, ooh, actually, this is not what you want to do. Nope. What I want to do is we have x coordinates and then we have y coordinates. And we have the min and the max. Ooh. Not necessarily. Yeah, I want all of them. Chords. Okay. Now, we're gonna sort on x. Okay, and say shorted x. Okay, so x is going to be small to large, and for the first one I'll take the starting position. Okay, we take the starting position. That will be, then let's say handle the tops. Tops equals what? Equals, this has to get smaller and smaller, right? So tops will equal to, we call it excess. Okay, excess 0, and then chords excess -1, because I want a biggest. I want a biggest on the so the top left corner. So that's the tops. The trees that need to be on the tops. Okay. And pre-k equals math.inf. And for I in range 1 to len excess. Okay, so we say x equal to excess I, and y equals chords x -1, the largest, right? And then we say current k equals this divided by this, y minus tops -1, 1, x minus tops -1, 0. If current this is smaller than previous this, and tops dot append xy, if smaller equal to, else if current one is bigger than, right? So we have bigger than, then I'll say so no matter what, we will add this. If it's bigger than, we pop the previous one. If it's smaller, then we have to include, which means we just say if current k is larger than previous k, then tops.pop, and then I'll append the current one. Let's do it in one line. Right? And then bottoms. Same thing. This is true, but this is going to be 0 because I want the smallest on the y. And previous is going to be negative because I want everything to be slightly bigger. So the same thing, xy, this is going to be 0. Right? I say if current k equals bottoms minus 1, yes, if current k is smaller than previous. Then pop and add this. So once we're done, handle the left and the right extremes. So the left extreme, so it depends on how many we have, right? And I already take, I take the same thing again. Dude, that's okay. That's okay. Because in the middle, in the middle we might, we might as well just set them. Okay, so top and bottom union the two, and then add whatever necessary for the remainder. Okay, so we say rest shall equal to set, oh shoot, it has to be this. So we can set tops, the union, set bots. Then I list these. Okay. Then we say for I in range 1 to len quotes access 0 minus 1. Right? Any additional? Rest.append. Zero quotes x0 I. Okay. XS0. And then XS minus 1, the rightmost. Okay. Trees. Oh. Okay. Wrong answer. I did it once last time. I'm just doing too fast. What did I do wrong? Zero, 2, 1, 1, 2, 2. 2, 4. 4, 2. 3, 3. Okay, shall we? Shall we 0, 2, 1, 1, 2, 4, 3, 3, and 4, 2. I have 0, 2, 1, 1, 2, 2. That is interesting. 2, 4, 3, 3, and 4, 2. Why did I have that? Doesn't make any sense, right? So let's see. What's tops? Top should be 0, 2, 1, 1, 1, 2, 4. That doesn't make any sense. 3, 3, 4, 2. How is 1, 1 is inside? Huh? Doesn't make any sense. Yeah, so we go on 0. Tops is 0, 2. And then we're gonna 1 to land this, right? So this is gonna be 1. Oh shoot. Else. Hey. Still not right. But this one's correct. 0, 2, 2, 4, 3, 3. So problem now is with the bottom. Okay, it's okay. So take a look at the bottom. Bots. 0, 2, 1, 1, 2, 2. How? I said if current is smaller, right, than previous. Oh. Oh, I need to recompute. Damn. All right, hold on. Then, geez, man. Current k shall equal to, I have to recompute the k. Right, if current k is larger than the previous, then this is previous, then we pop this, which is here, then we recompute. Right, because this is previous, this is current. Recompute, and then how? If current k is smaller than bots, we pop, right? So we pop this. Now we compute these two. Yeah, when 4, 2 comes in, this is a 0. This is a positive. It doesn't make any sense. Yeah, so this is fine. Oh, this is 3, 3. Dude, I didn't see the 3, 3. Oh, shoot. Oh, okay. Yeah, makes sense. Ah, it's while. It's while. This is current. It's larger than pre. This and this. If so, current is x and y, right? So x and y, and then this, and then these two. Then we'll, if this is larger than this, then we will pop. Then we say this is larger than this, then we'll pop. Then we need a starting point, right? Okay, I know what the problem is. So say while len tops is larger than 1 and minus 1 2 0. Len bots larger than 1. This divided by this is smaller than this divided by this. Okay. Actually, we can copy this. Just make some changes. First of all the tops, bottoms, and this is smaller, which is the current is smaller than the previous, right? Then we'll pop the previous. Then we do this and this until we have only one left. And we'll add a new one. What the heck? That's still not right. I still have 2, 2. That is ridiculous. I mean, 4, 2, this is a 0. Right? 4, 2 comes in. And then this is 2 to the 0. The first is 0. Second is 1. And bot shall pop. I don't understand. I do now because it's while. This should be right. This is one of the less difficult problem. I remember the solution I'm using is actually, I think, is from the previous. I kind of remember how the official solution drew the outline. For me, I first find the top and bottom, right? I found the top and bottom trees for each column. Then I draw the boundary at the top by connecting all the top trees of each column, connecting the adjacent top trees, connecting the top trees of each pair of adjacent columns. The only requirement is that the slope of the new pair must be smaller but equal to the previous pair. If this cannot be satisfied, we pop the previous tree. This popping continues until we have the current pair satisfies the requirement, slope requirement, or if there is only one tree left for pairing. Similarly, we do the same for the bottom, right? For the bottom trees, except the slope requirement is that the new slope must be bigger or equal to the previous slope. Then we're done. All right, so I call this n trees as on, and this is I want to call it on log n. This is on log n because that's sort. Not necessarily. I would call it on log n because of these are all on because everything is pushed once or popped once. So this is on. This is on. This is on. These are on. If all is different, then that's on log n. So I will call this on log n. $84 test cases. So we have more test cases this time, right? 88. Yeah, I think this is my solution. Monotone chain, yeah. Cross product. Yeah, I think we can still use cross product. Yeah, on the top is a right turn, and the bottom you can say it's a left turn, but if we go right to left, it's a right turn as well. What's a cross product? I actually like my current solution. I think my current solution is easier among them. It's monotonic as well, and we use slope. Jarvis algorithm. Run. Oh, I'm using this one. But how do you sort these things? Bottom to top. Bottom to top. A convex hole. I mean, I go 2 round, and I still like this idea of going 2. 1 pass on the top, other pass on the bottom. But this is the stack. Hmm. Hmm. Orientation. Isn't it just same as this one? Oh, slightly different. Oh, the other one's polar angles. Yeah. Actually, this is very similar to this one. You know what? I think I would just remain with my solution. Orientation. More counterclockwise than P. Mm-hmm. We want a most counterclockwise. Oh, the more counterclockwise, yeah. That is true. Cross product. Cross product is... Damn, I forgot cross product is not multiplied by sign, right? PQ and then QR. Yes, it's this angle. It's PQ and QR. Because if this is more counterclockwise than this, so Q is more counterclockwise. Actually, Q is more counterclockwise to P than Q. Yeah, so P is here, Q is here, right? So we want to say this is more counterclockwise than this, which means if we have this vector and this vector, if this one is here, then it will be a acute angle. This is not an acute angle. Wait, these two are the same things. Isn't that the same as this? This, yeah, it's the same thing, right? Let's see what we're talking about. We have PXPY, QXQY, RXRY, right? Say, is Q more counterclockwise than this? Which means if we connect from this, we need to connect to R, now we need to connect to Q, which just means we want the slope of qy minus py divided by qx minus px to be smaller than ry minus py rx minus px. And if we rearrange that, I think we'll get this thing. We have qy minus py times rx minus qx smaller than ry. Yeah, that's exactly the same. It is just the slope. It's just the slope. Okay, so yeah, that will be it. That will be it. You wanna come back to this? I mean, nah, we got 15 more minutes already. Yeah, we'll do this another day. Okay, that will be it. I mean, it's not too bad. We solved a difficult question. I mean, we solved it before, and to be honest, this is not really the toughest one. And I also failed it once, so it's not perfect, but that's the key, right? The slope. The slope does work on both. Anyway, all right, I will see you guys tomorrow.